Hello and welcome to another episode of the Blockchain Interest Group podcast with your hosts Krishna and Nikhil. BIG is a consortium of individuals who are interested in blockchain and distributed ledger technologies. You can learn more about us on our website big-org.com or follow us on our social media using the links in the description down below. Before we begin, a quick disclaimer. As with all the videos on this channel, anything and everything that you hear in this podcast is meant for educational purposes only. Everything that we discuss on any of the projects are our personal opinions and not meant to be taken as financial advice. So with that, our topic for today's podcast is the Waves platform. Waves is a global public blockchain platform founded in 2016. As of today, it is a decentralized blockchain platform primarily focusing on custom blockchain tokens. To compare with other projects, Waves positions itself as a direct competitor to Ethereum and other DAPPS platforms. It has many tokens launched on its platform. In terms of numbers, I would say it is second only to Ethereum. Waves today is primarily known for its decentralized exchange, which seems to be popular among the various decentralized exchanges that are in the market. Also, the team claims the Waves blockchain to be the fastest production-ready blockchain in the market today, with speeds of up to 100 to 400 transactions per second. The platform attributes this to an innovative new protocol called the Waves NG protocol, which is an adaptation from the Bitcoin NG protocol. Today, we're going to be looking at how the Waves platform works and how it differs from its competitors in this space.
That sounds interesting, KK. Can you expand a little on some of the key features, like the consensus mechanism that Waves follows?
Sure. So Waves follows something called a leased proof of stake consensus mechanism, which is actually, one can say it's a proof of stake with a twist. So there are 100 million Waves tokens in total, all of which are pre-mined. When the platform first began, a user needed to have a minimum of 10,000 Waves in their wallet to have the ability to run a full node on the network. As of today, this minimum is reduced to 1,000 Waves. Since everything is pre-mined, no new tokens are created, and therefore the existing Waves tokens effectively act as a fuel for the platform. So how this works is that the transaction fee for any transaction on the network is 0.001 Waves. So any person using the Waves platform, whether for trading or for conducting ICOs, needs to purchase Waves at the market rate, and that is what creates a demand for the token. The miners receive transaction fees generated on the network based on PoS consensus. The model is called leased proof of stake because those users, let's say who do not have 1,000 Waves in their wallet, can also draw revenue from the platform with this leased proof of stake model. So let's say you had only 50 or 60 Waves in your wallet. You could lease them to someone with a full node and receive a share from the transaction fees that are earned by the full node owner, which is also called the miner. The percentage of revenue splitting is freely decided between the leasee, that is the full node owner, and the leaser, that is the regular user who has leased his Waves to the node owner. So how Waves has actually made it even more interesting is that when someone leases their Waves to a node, technically the node is supposed to share with them a fraction of the transaction fees it collects, which is actually in the form of Waves tokens. But as you know, Waves platform is also a custom blockchain tokens platform, on top of which several different projects launch their own tokens, just like you have ERC20 tokens on the Ethereum platform. So in this case, depending on which node you're working with, the node owner may choose to pay the leaser either entirely in Waves tokens or pay them also in the form of some of the custom tokens that have been launched by various projects on the Waves platform. So this inherently generates a supply for the custom tokens launched on the Waves platform. So for example, there is a pretty popular project that has launched their tokens on the Waves platform. They can strike a deal with some of the nodes to distribute their tokens to the leasers instead of paying completely in Waves tokens. So this is pretty much how the economics of and the supply and demand of these tokens would work on the Waves platform. So this is basically the gist of how leased proof of stake consensus mechanism works. One of the most interesting aspects, technical aspects of the Waves platform is actually their innovative NG protocol, which they have borrowed from the Bitcoin NG protocol. and they attribute this innovative NG protocol to allow them to execute up to 100 to 400 transactions per second. Nikhil, do you want to go into what the Waves NG protocol is and how it works, and like what has been borrowed from the Bitcoin NG protocol?
Sure. So this particular paper or this particular NG protocol addresses is actually came out as a paper to address certain weaknesses in the regular proof of work blockchain systems, right? So even actually proof of stake blockchain systems. So one other thing about blockchains is the idea of a block and the creation of adding of transactions to a block, right? And so blockchain systems can process transactions, and the maximum rate that these transactions are processed is limited by the choice of two parameters. One is the block size and the other one is the block interval, right? So the block interval is the amount of time that passes between the creation of two blocks. Okay, so you can increase the speed by reducing the block interval to solve the latency idea. But this is basically going to have a problem, a security issue, because now if you have less time for the block to propagate across the network, and because the block is not propagated, this increases the probability of forks, right? So you will have a lot of forks happening, and there is basically then it becomes much harder to then determine which is the real block, a real fork, and which one is the real blockchain, right? So that basically is a challenge with when you reduce the block interval. Another thing you can do is you can increase the size of the block, right? So instead of you can keep the interval the same, but you can try to jam in as many transactions as you can into the block, right? So here again, the throughput of the system is bounded by the maximum block size. But when your block size becomes larger, then there is another type of attack that can come. One is basically you can if you keep your block size unlimited, for example, it can result in a DOS attack, right? You can just keep having a lot of people keeping on adding transactions, and then the block size never finishes, and then propagation of that huge block takes more time, right? Another one, the thing is that if you have larger block sizes, it will lead to longer times for processing the block and validating it. And if there is any problem within that block, then that entire block has to be discarded, and then a new block has to be generated. And that again takes increases the latency. So the way that the Bitcoin NG paper actually addresses this is quite innovative. So just to give a little bit of background on the Bitcoin NG paper, essentially it is a technical white paper that was presented in the Usenix conference by Itai Ayal, Adam F.A., Emin Gunsira, and Robert Van Resse, and from the and Cornell University, right? So this is basically an academic paper, and what they actually did was they kind of went away from this idea of blocks being groups of transactions, right? So what they said is, okay, instead of having a block be a set of transactions, why can't we just have one transaction be a block, right? So essentially directly just add transactions. So obviously this means that you will have a whole bunch of transactions being added to the chain. But how do you actually control this, right? Who decides how these transactions get added to the chain? So they came up with this idea of what is known as a key block and what is known as a micro block, right? So the key block is used for the election of the leader. The leader is the person who actually can add blocks to the chain. So the first thing basically in Bitcoin NG, basically the election of the leader is still your classic puzzle solving and proof of work puzzle solution. And in Waves, basically they're using the proof of stake consensus mechanism, the least proof of stake consensus mechanism, to determine who is the leader. But the key block, when it is created, does not actually contain any transactions in it. All it has is the public key of the leader, right? The public key of the person who can actually add transactions to the chain. Okay, so as soon as the key block is generated and sent out, right, the key block basically contains the, obviously it's a chain, so it contains a reference to the previous block. This can be a micro block or another key block depending on what was immediately before it. And essentially the once this key block is generated, all the miner immediately starts adding micro blocks for to the ledger. Okay, and each micro block is basically signed by him with the signature. So since the key block has his public key and he is signing this particular block with his signature, it is easy to validate. Okay, fine, this has been signed by the person who is authorized to add it. Okay, now this is a continuous process. He will keep adding micro blocks to the chain until a new key block comes down the line, right? Now in the proof of work case, obviously this is controlled by the difficulty of the puzzle. In the proof of stake for waves, what they are doing is they are basically saying that the key block is generated once every minute, right? And the what is that? The micro blocks basically get created once every 10 seconds. Okay, so the way this works basically is that, okay, as soon as he gets a key block, he has got basically 1 minute to put in as many micro blocks as he wants, and then basically the transaction fees from all of those transactions get added to become his reward, right? Now there again another innovation has happened. So essentially the remuneration for this basically is such that the reward for the transaction fees is split. So only 40% of the transaction fees is given to the current leader or the person who is actually adding the transaction. Okay, 60% is given to the subsequent leader. Okay, so this is the reason why this is done is this is to kind of encourage that the subsequent leader basically doesn't try to steal transactions. So obviously the subsequent leader basically after 1 minute, right, he creates a key block. In the key block he can point to any block, previous block, right? So if he points to, like, say directly the previous key block, right, he's essentially, and then tries to add all the blocks that previous key block added to his own block, he's essentially trying to steal those transaction fees, right? So this is actually not useful to him because he will get only 40%. Whereas if he acts like a good as intended and just directly connects to the last micro block that was generated, he gets 60% of all the micro blocks, right? So that's the incentive for him, right? Second thing is, if a leader forks the chain, so forking is basically the double spend idea. So if they try to create a double spend, right, he can create 2 micro blocks of the same parent, right? Then what happens is that there is a fee that is given to anybody who actually detects this. Okay, and the leader who actually does this is punished by revoking the subsidy revenue, right? So he loses all his fees. Okay, and the person who detects the fraud wins a nominal fee. In addition, he gets, if he's a miner, he would become the valid link in the chain, and obviously he gets the 60% fees, whatever that the fraud actually lost, right? So this 40 plus 60% split is to kind of handle this particular problem with forking. Okay, now NG protocol, Waves NG protocol has one more interesting thing. One is basically the idea of a liquid block. Okay, personally I think it's more of a, I don't know, a nomenclature kind of a thing for Waves, but the idea essentially is that, okay, they consider this collection of a key block and all the micro blocks that have been generated by the leader that key block has nominated, or that the public key, whose public key is in the key block, to be one large liquid block. They call it a liquid block, right? And the liquid block is because it is flexible. It depends how many transactions are there and the network speed in order for it to be able to load the number of transactions. So it can be anything between 100 to how many transactions they can. So the 100 to 400 speed right now is actually based on the network performance of the Waves network rather than any kind of arbitrary limit per se. So that's the way that the Waves NG protocol works and has been implemented, right? And this is basically how they get that particular speed up, right? One final thing, basically, the once a transaction is added to the chain, okay, the can be respent only after a maturity period of 100 key blocks to avoid, non-mergeable transactions if there is a fork. Okay. Anyway, so that's basically pretty much what I have on Waves NG. And yeah, I mean, it's a pretty interesting kind of an implementation of that protocol.
Do you see any drawbacks to the NG protocol, like something that?
Yeah, so I mean, obviously it's a little more complicated because again, in practical cases right now, when you say it is your size of your block is limited by the transaction speed, right? So obviously, suppose you are a miner that has a slow transaction, I mean, there is this idle network latency or something. You might, end up adding a lot of nodes before the key block reaches to you. Next key block propagates, right? And then, you might have a fork problem over there. Um, the uh, the the other thing about this is that so I think that basically they have actually changed that. So right now I think they've put a upper limit on the number of transactions. So I think it can contain up to 65535 transactions, 65,535 transactions, and so that might be something that you can do, that they are trying to fix. Then this whole 40%, 60% calculation, right? That actually is pretty interesting. But again, what happens if, each one, and it kind of breaks down because, see, the cost of a transaction, if I'm not mistaken, is 0.001 waves, right? That's what we have this thing. So,
Right.
so that is essentially the fee that is being paid. Correct?
Correct.
Okay. Now, if you're saying only 40% or 50%, this whole 40%, 50% calculation works out. My only thought is that, okay, suppose you have transactions that are significantly more expensive, where the payoff for double spending or fraud is much more. Okay, then
Okay.
they may be, okay to even risk
The
um,
going with the
the
40% and
going with, yeah, losing their subsidy, right?
right.
So that I think is something that doesn't get elaborated over there. And I think that's a weakness, not so much as an NG protocol as in that the waves thing, right? And that's kind of like I mean, with Bitcoin or with Ethereum or the others, they calculate it as it's that fee itself is a market driven feature. You know what I mean?
Right.
So there they might be, so if it is an expensive transaction or a large transaction, you would probably increase the fees so that that motivation is there to be uh, that okay, you'd lose a lot more. But I don't see that actually happening here, because I mean, I don't know, maybe I missed something, but uh, in my understanding is that even if the transaction is for 100,000 waves, the transaction fee is only 0.01.
Mm-hmm. Right.
0.001.
True. Great. So I think that sums up the NG protocol pretty well, and like the pros and cons. And it is fairly new. I would say it has been about 5 or 6 months since it has been activated. So far, yes, I mean, Waves claims it to be, I mean, the Waves blockchain to be the fastest production ready blockchain in the market. So let's see how it runs going forward. So moving on, let's speak a little bit about the governance mechanism on the Waves network. So Waves imagines itself as a complete end-to-end financial ecosystem where people can store their crypto funds, companies can launch their tokens, and have them listed on their inbuilt decentralized exchange. The makers of the platform wanted to have some sort of a voting or a governance mechanism where the community itself can self regulate its ecosystem. So, for this purpose, the Waves team has actually launched two separate tokens. One is called the Waves Community Token, or the WCT token, and the second is what they call Miners Reward Token, or the MRT token. So, Waves Community Token, as the name suggests, stands for something that can be used for voting on community based decisions. As far as I know, as of today, there is no clear cut use case for which it is currently being used on the Waves network. But in the future, my guess would be that, let's say there was some sort of a fund for which various projects were competing, and the community needed to vote on which which projects they think are the best. Something like a Waves community token would be used for doing this sort of a voting. So this is just a guess. From the Waves team, the only clarification on the purpose of Waves community tokens in the future is voting on community based decisions. So possibly because of these reasons, projects may have an incentive to airdrop their tokens to Waves community token holders, which in turn would create a value and a demand for their tokens. Miners Reward Token, or the MRT, on the other hand, is a token that is given to miners for mining. So, like WCT, the exact purpose for this token as well is not clearly defined as of today. But as the team has told in the past, it will be used for voting on any technical parameters on the network in the future. So probably something like voting to change the transaction fees on the network, or perhaps similar issues. So as such, the miner reward token currently are issued to miners who can in turn distribute it to leasers, or a simple user can simply purchase them from the free market on the Waves decentralized exchange. So that is pretty much how the governance and voting is supposed to work on the Waves network in the future, on community based decisions and on any technical parameters that need to be changed on the network. That is what these tokens would be used for. Apart from this, I guess there is also an activation protocol that the Waves network currently follows. Nikhil, do you want to elaborate on that?
Sure. So Waves basically has an activation protocol for the software changes that are being done, right? So unlike other blockchains, Waves has a very active and continuously updating software for the software team, active software development team, and the software keeps getting changed. So the way this works basically is that every feature that is added to the software, the Waves node software, is got a ID. It is a sequential ID and it's a unique ID. Okay, so every time a new version of the software is made available for for miners or for people to use, each of these nodes basically have a list of IDs that denote the features that are supported by that node. So when this particular node is downloaded by a miner and it is used to create keynodes or add transactions to the block, the node basically adds a list of the IDs that are supported by it, as part of its voting mechanism, right? So every time a transaction is added by that node to the block, the the list of IDs and then features that that node supports is provided. Now, the once this feature is added, once a new feature is added, the node basically monitors the network, right? So since it every transaction has a list of IDs, it can just look at the transactions on the network to see which set of nodes are available. I mean, have been updated to the set of features that it has, and if up to 80% of the nodes in the network for the past 10,000 transactions indicate, I mean, have a particular ID in them, so they then basically we can say that 80% of the network have that particular feature, then that feature is activated. Okay, so once a feature is activated, then basically that's an indication to the rest of the nodes that they need to upgrade their software to match that particular feature, include that particular feature, right? And they have another window of 10,000 transactions to do this. Once that window is completed, the second window is completed, the ID is considered to be uh, uh, sorry, the in the first window, basically the ID is the feature is considered approved, and in the second window of 10,000 transactions, if 80% of the nodes have it, the feature is considered activated, and all the nodes that don't have that feature will then stop functioning. Okay, and it will basically throw a log warning, log error, saying that okay, this particular feature is not there in this particular version of the software, and then that the miner needs to upgrade. So that's basically the kind of informal automatic governance that is happening on the software.
Great. So moving on, let's talk a little bit about one of the top features of the Waves platform, that is the decentralized exchange. As I mentioned earlier, the Waves wallet comes with a decentralized exchange, and which actually is built into the Waves wallet itself. So from a top level perspective, one can say that the decentralized exchange is decentralized but not entirely trustless. How it works is that the order matching happens on a centralized server, but the settlement of any trade happens on the blockchain. The centralized server matches incoming buy and sell orders. However, it does not have access to anyone's funds. The funds are at all times, kept in your own wallet and secured by your own private keys. When the users place buy and sell orders, the server matches the buy and sell orders and initiates the transfer on the blockchain. The point here is to sort of meet midway between completely centralized exchanges and completely decentralized exchanges. Waves is somewhat in the middle, as the matching of orders happens on a centralized server. So this makes the process pretty fast. The settlement, however, happens on the blockchain. So this makes the user funds secure, as the users have custody of their funds in their wallets at all times. So it is never stored with a third party, unlike centralized exchanges. So for any tokens that have been launched on the Waves platform, they automatically get listed on the DEX the very minute they have been created. But for other currencies like Ethereum, Bitcoin, or fiat currencies like USD, Euro, etc., the Waves platform utilizes what are known as gateways. These gateways are centralized, so basically they are trusted entities and not entirely trustless, although their operations would be somewhat transparent. So as users of the network, you can see all the addresses held by the gateways to verify if they actually hold all the currency that they're meant to be holding or not. I guess the best comparison for a gateway would be an entity such as Coinbase. The centralized gateway maintains both hot and cold wallets to execute asset transfers from person A to person B. So another important aspect of the Waves decentralized exchange is that's worth mentioning is the liquid token that they had launched about 4 or 5 months back. So the liquid token is basically meant for something that is called market making. Anytime a new token is launched on a platform like Waves, one of the key challenges for the project's team is to generate liquidity for the token right from the start. Just as an example, if a project conducted their ICO on the Waves platform, let's assume that the team marketed the project very efficiently on various channels like mainstream media, social media. The general users would already have an awareness about the project. So when the token gets listed on the decentralized exchange, there is a good chance that many people would be already ready to buy and sell their token. So for a popular project, generating liquidity on the exchange in the initial days is not too tough. But for projects that are not so popular, that have probably not spent a lot of money on their marketing, to spread awareness about them among users, generating liquidity on the exchange can be a challenge. So this is basically where the Waves liquid token comes into play. The liquid token is a separate token on the Waves platform, the purpose of which is to create a mechanism between market makers and issuers. The market makers are basically the buyers and sellers in the market. The issuer is the entity whose tokens are being traded. So as the name suggests, the purpose of the liquid token is to generate liquidity for a token when it has just been newly listed on the exchange for buying and selling. How this works is that there will be a pool of market makers, that is buyers and sellers on the exchange, who will be willing to trade your token when it is listed on the exchange. As the issuer, you pay these market makers for buying and selling your tokens. The only way for you to pay them is by using the liquid tokens. So an issuer, let's say your ICO has just completed and you're launching your token on the DEX. If you want liquidity for your token, you purchase a certain amount of liquid tokens from the free market. And you purchase the service from market makers by paying them in these liquid tokens. What the market maker does is that once they receive the liquid tokens from the issuer, first thing to do is burn 10% of the received liquid tokens. So this reduces the total supply of the liquid tokens with every burn. Using the remaining 9% of the liquid tokens, the market maker converts them to BTC or Waves or the issued token itself and buys and sells them to trade with the issued token in the free market. So this basically spurs off the buying and selling of the issued token. So in a nutshell, the liquid token provides a mechanism to guarantee the buying and selling of a newly issued token on the exchange when it has just been listed. How much volume you want to generate for your token will decide how much liquid tokens you will need to purchase from the market to give to the market makers. As of right now, I'm not entirely sure up to what extent the liquid tokens are being used on the platform for this specific purpose. Once smart contracts are implemented on the Waves platform, I believe this process will be more streamlined and automated for a more reliable and dependable market making. So that's basically market making and the use of liquid tokens in a nutshell. So about the DEX as a whole, my general opinion would be that Waves has a pretty impressive DEX in the market right now. It is surely not alone. There are others like Ether Delta, IDEX, and many others. So there's definitely a lot of competition. However, I think Waves has one of the more popular DEXs in the market right now. The daily trade volume currently is about $5 to $6 million, which is higher than most DEXs, I would say. In terms of the available gateways, as of today, I believe they have gateways for USD, Euro, Turkish Lira, Bitcoin, Ethereum, Zcash, and Monero as well. So as of right now on their DEX, you can hold and trade between these currencies and all the tokens that have been launched on the Waves platform. You cannot currently trade any ERC20 tokens on the Waves DEX, however, at this point. So once they implement smart contracts and atomic swaps on the mainnet, I believe trading ERC tokens will also be ERC20 tokens will also be possible at that point. So and I think once that happens, the trade volume will also grow higher than $5 or $6 million that it currently is today. So that sort of sums up the Waves decentralized exchange and how it is today. The next thing that I think is really worth looking into is actually the smart contracts on the Waves platform, which is pretty different from how Ethereum has approached the same thing. So Nikhil, do you want to go into how smart contracts on the Waves platform will work?
Sure. So this is actually quite interesting. So on in May, at the end of May, basically, they came out with a white paper on their smart contract language. So basically, the idea essentially is that for Waves, they are actually going to implement smart contracts in multiple stages. So in the beginning, they will have a very constrained Turing incomplete language, which they will be using for scripting and only for certain with certain functionality. But at the same time, they will be actually building at a foundational level the platform for actually extending that, so that in a second stage that they can actually extend that into a more complex or a more complete smart contract language. So the smart contract language that they've come out with is called RIDE, RIDE, and in the first iteration, it basically has uh, two level mechanisms. First one is the smart accounts, and the other one is the smart assets. Okay, so the realization of their smart contracts will contain this smart accounts concept, and so I'll get into the smart account context and smart asset just a little later. Let me just quickly talk about the language itself, right? So the syntax of the language is similar to a functional programming strongly and statically typed language. So the idea essentially is to keep it as transparent and as what do you call it, secure, I mean safe from or let's say programmer mistakes as possible. The syntax is similar to F sharp. F sharp is a statically typed functional language available on the .NET platform. Um, so the so yeah, but they don't have they will not be having complex data set types like collections or lists in the first stage, and they will not have functions. It'll be, and the only control structures would be the if then else control structure. There won't even be any loops. Okay, so let's go into smart accounts, right? So what they are doing is they're trying to create a direct generalization of the Bitcoin scripting. Bitcoin scripting is basically a Turing incomplete language, but at a slightly higher level, right? Uh, so this idea of a smart account is the following. Before the transaction is submitted for inclusion in the next block, right? The account basically runs the script, right? And checks if the transaction meets the criteria or the requirements defined in the script. So the script is attached to the account. So the account can validate every transaction as per the script before confirming that it is included in the block. It is submitted for inclusion in the block. Okay. The main requirement is that this script can be run for the price of a normal transaction with a predefined fee without any additional gas or other costs. Okay, so this is the main challenge, or this is the main thing that they want to make sure is that okay, it is not computationally expensive. In fact, actually, it is actually computationally predictive, right? And that is the reason they have actually taken out all these loops and functions calls and everything, so that it is a statically predictable execution time. Okay, since Waves is built on an account based model, so there is an account for everything like Ethereum or Next, we can set these security scripts on the account transaction. And since it is a predictable execution time, the cost of that particular transaction also is predictable. And so it basically becomes your transaction fee plus a predefined predicted fee. Okay. Now, in their vision, smart accounts cannot send transactions to themselves. They cannot send transactions to other places, or they cannot transfer funds. All they can do is read data from the blockchain, so maybe the height of a block or a signature from a transaction, and based on that data that they have read, return a result, right? And that result basically should validate the transaction that has triggered that particular script. Okay. Now, the second way of using this, now obviously smart accounts. So by this description itself, we realize that smart accounts is quite constrained, and it's essentially kind of like a security mechanism for an account, right? It's you can actually set a security script for an account, but you cannot do very interesting things with it. Now the second way they have second object that they've created is the smart asset, right? Now if we want to apply constraints for a specific asset, right, that is its specific token itself, Waves token itself, then obviously there's no point in putting the script against an account. So they have this concept of a smart asset where the script would be attached to the asset and will work in a similar way to the smart account, except that the transactions for such assets would be valid only if the script returns true. So the script can verify proofs from a transaction, check if there is an escrow that approves the transaction and the operation of the asset is not locked. So simple things like that, creating, issuing a new transaction, reissuing a transaction, burning a transaction, all of these actions can basically be constrained or, validated programmatically using a smart asset. So at this point in time, this is the extent of the smart contract implementation that Waves has done. And they've actually recently deployed it on the testnet. The plan basically is to run it on the testnet for some time, make sure that it is stable before it goes into production. So again, when Waves goes by, when we say smart contract on Waves, people should not get the mistaken assumption is that it is like Ethereum or Hyperledger or any of these other platforms that have smart contracts. It is a very constrained and a very specified set of functionality that they're releasing, and they're releasing it in a very deliberate manner, mostly to kind of enhance or improve the decentralized exchange functionality, right? It is not, most of the possible use cases or examples that they come out with is mostly around that particular decentralized exchange concept, right? And enhancing that concept or bringing more functionality into the coins in that concept. So yeah, so that's basically how they're approaching smart contracts.
So just adding to that, so like you mentioned, since the transactions themselves are predictable in the case of Waves smart contracts, that is basically how it does away with the need for something like gas on the Ethereum platform.
So the Waves does not actually do away with the cost of an execution, right? So essentially, a program is a program. It's a series of operations. Each of these operations basically have some resource cost. But what Waves is trying to do essentially is it is trying to be able to very clearly define and constrain the cost itself, the number of operations that can be done. Okay, and the way it is doing that is by constraining the language itself. So that is why it is non-Turing complete, and they've done only certain things, and they've not added collections and things like that. Ethereum, on the other hand, essentially did not do that. They made it Turing complete in the beginning itself, so it is completely flexible and all that. So what actually there is a problem is that, okay, there is no very clear prediction as to what is the cost of a transaction, the gas cost of a transaction on Ethereum, right? So I would be
Right.
able to run a smart contract with a certain amount of gas for a particular, with a particular set of data. But your data might cost more gas, it might cost less gas, it might cost, it may not even, you may not even be able to execute it because it goes across beyond a gas limit. And the reason for this is basically depends on what kind of data you're sending, right? As well as what kind of operation path or what kind of path of operations that your data triggers versus my data, right?
Right.
So that is basically the fundamental problem that Ethereum is constantly facing with gas, right? Which is what Waves is trying to solve, or
Right.
rather, not even solve, to kind of avoid. It is,
Circumvent that whole thing.
yeah, circumvent that whole thing. So it is invariably going to face this issue when it starts loosening up the what do you call it, constraints on the language, right? So once RAID starts adding loops, and it starts adding functions and all that, it will inevitably become more expensive, and there would be an operations cost. But what I think the Waves team is trying to do is they're trying to approach it in a very systematic manner, in a very constrained manner, so that they have a lot of visibility into what that would be, what that cost would be, and basically also to try and see if they can get away with not introducing certain features if until their community actually demands it, right? So if they, what is the point of I think what is their thinking is, what is the point of introducing links if nobody is going to use loops if nobody is going to use loops, right?
Right.
Or what is the point of having functions and recursion if that's not going to be used in a, so but the problem I have with that is it's kind of like a self-fulfilling prophecy, right? If you don't give the feature, then nobody's going to obviously nobody can use the feature. People might ask for it, but they might even go back and say, okay, fine, maybe that's what Waves is not meant for that, and they won't care.
Right. Makes sense. So, would you like to quickly summarize, with the NG protocol and with, with the smart contracts, what you think of Waves in general altogether?
So overall, I've been kind of impressed. Waves is basically one of these very quiet, nobody talks about, or no, it's not heard in the news much, but it seems to be these quiet giants that are sleeping over there. It's one of those. The team seems to be one who's kind of plugging away at it and coming up with new things and all that. There's a certain amount of, they are basically okay with being the second or even the third to implement a particular feature or a particular what do you call it, innovation. They don't want to be the leaders. They just want to be the ones who actually look at all the things that are happening out there in the space and try to pick what they feel would be best suited and meet a business need rather than all about technical innovation, which is great, which is fine. And the only challenge I have, or rather only issue I have with that, is that it's kind of a catch 22. I don't kind of blame them too much also. Is that because of that, there's actually a dearth of documentation, there's a dearth of tutorials. It's kind of difficult to actually get into the Waves community from a developer perspective, unless you're kind of like hardcore and you spend a lot of time on it. So it's whereas if you want to get into Ethereum, it's literally right now, it's literally you have tutorials that can handhold you from right down from setting up your computer, and all the way down to the tool chain, and then creating the contract and deploying it, right? So the that kind of thing is not there in Waves right now. That's probably fair, because Waves, to be honest, moves also quite fast. They change things, and so on the whole, yeah, I think they're doing well. I wish them luck. Uh, there are a few things on the NG side, like I mentioned about the my hypothesis on the fixed cost of Waves transactions fees coming to bite them, and also on the smart contract side, the fact that it's very constrained in terms of functionality kind of naturally limits their usability for other things. But yeah, those are things they probably have already taken into account and probably have a plan for.
All right, folks, that concludes our podcast. We hope that you found this episode on Waves platform useful. Please leave us your comments in the comment section below. Follow us on our social media. We are on Facebook, Twitter, LinkedIn, and also Telegram. The links for all are in the description below. Thanks again for joining. See you next time.